All right, everybody, today we are looking at negative and zero exponents. Okay, so first what we need to do is figure out what is a negative exponent, or when would it even come up. Okay, so let's start with a specific example because you know how to do this one already. Let's do x to the third over x to the sixth. You know how to do this one already, so take a quick pause, write down what you think the answer should be. Hopefully you didn't write x to the third. Hopefully you wrote x to the negative third, because you should be subtracting 3 minus 6. That gets you negative 3. So the question is, what does this x to the negative 3 mean? Well, I think the best way to figure that out is to look at this problem in a different way. X to the third is just 3x's. X to the sixth is 6x's. Right? Okay, so if we look at this problem a different way, like if I saw it written out like this, I would probably not subtract exponents or anything like that. I'd probably just say, I would just start canceling x's and see what I have left. And here's what I have left. I have nothing left on top, but remember those all canceled out to 1s because x divided by x is 1. So I would have 1 over x times x times x, or 1 over x to the third. So x to the negative 3 is the same thing as 1 over x to the third. Okay, this brings us to what our actual rule is. X to the negative n power is always equal to 1 over x to the positive version of that power. Okay, so if you want to think of it in terms of a positive exponent, you can. You just got to make it into a fraction then. Okay, so here are I'm going to show you some tricks with negative exponents to make them easier. Okay, you can still, all of our same exponent rules apply to negative exponents, but sometimes the negatives can be too much. But you can always change a negative to a positive exponent just by switching its position from numerator to denominator or denominator to numerator. That's my biggest trick that I can offer you. So like, let me explain this one. Let's say you had a really big, complicated expression like this. So if you wanted to, you could actually just straight up subtract those exponents and then figure everything out after that. But let's say you're really not a big fan of negative numbers. You could turn this into an expression with all positives. Here's how you would do that. You would take each of your negative exponents, move it from numerator to denominator or denominator to numerator, and write it as a positive exponent. This would give you a new expression of, let's see, x squared, our original x squared would still be in our numerator. And that would be it. The rest would, our x to the negative fifth is now in our numerator, and it's x to the positive 5. Our y to the negative 6 is now in our numerator, and it would be y to the positive 6. Okay, then let's look at our denominator. In our denominator, z to the fourth was the only thing that stayed. And it acquired a y to the third, positive 3 now, from the top, and a z to the positive 4, also from the top. Okay, now you could simplify this expression. Okay, so on top you get x to the 7th. On the bottom, you're going to get a z to the 8th. And then with those y's, you still need to subtract the exponents. Y to the 6th over y to the third is y to the third. And those will go on top. We've got 6 y's on top, 3 on bottom. We'll have 3 left over on the top. Now, if you had just subtracted those exponents, would you have gotten the same answer? Yeah. Yeah, you certainly would have, except you would have gotten a z to the negative 8. Okay, which is the same answer and is just fine. So, and you don't have to switch all of the exponents. You could just switch 1 or 2. But my big thing is that, and I'll try to reiterate this as much as I can, x to the negative 4 is the same thing as 1 over x to the fourth. But the big thing to remember is that because of that reciprocal nature and the way reciprocals of fractions work, 1 over x to the negative 4 is the same as x to the positive 4. Okay, so there's always a way to change a negative exponent into a positive exponent if that's easier for you. That said, you can just work with the negative exponents too, and that's certainly okay. Here's what you need to do for these examples. I want you to try each of these examples, okay? But I want you to write your answer in 2 ways. I want you to write it without a fraction and using both positive and negative exponents, so nothing in a denominator. Okay, so try writing it in 2 ways. With no denominator, so you will probably need to use either positive or negative or both types of exponents. And then I want you to write it a second way using only positive exponents. Okay, so you can use fractions in the second one, but you should only use positive exponents. So try writing these in 2 ways. That'll get you good practice at kind of manipulating your answers. All right, so this first one, I would just initially subtract my exponents because that seems easiest. I get x to the negative 2. That's the first way. I'm going to do my first ways in black and my second ways in red. Okay, that's the first way. There's no denominator there. I've written it without a denominator. That's not a fraction. That's my first way. If I want to convert that to a positive exponent, though, I can change it to 1 over x squared. That's my second way. Both answers are acceptable. Those are both good answers. They are the same thing. That's really important to know. Okay. Next one. Now again, I could switch that x to the negative 3 into a positive exponent before doing anything. You know what? I'm not going to do that. I'm just going to subtract. Negative 3 minus 4 is negative 7. And that makes sense, right? Because if I were to move that negative 3 to the denominator, it'd be an x to the positive 3 on the bottom. I'd have 7 x's in my denominator. That's x to the negative 7. Again, that's my first way. If I want to change it to only positive exponents, I'd have to use 1 over x to the 7th. That's my second way. C. This time we're adding our exponents. Yes, we're adding our exponents. We get x to the negative 3. Again, that's my first way. I can write this as 1 over x to the 3. Oops, sorry, that one was supposed to be in red. That's my second answer. I'm hoping those first 3 examples were reasonably straightforward. Where things get a little bit tricky, just a little bit, is when we bring numbers into play. Okay, so here we have power of a product, so we need to distribute that exponent to the 3 and to the x to the negative 5th. So 3 to the 2nd is 9. X to the negative 5th squared, that's a double exponent, so we multiply those exponents, we get x to the negative 10. I should have written that in black, that's my fault, because that's my first way. This is written currently without any fractions, nothing in the denominator. Okay. A second way that I can write it, I only want to flip around the x to the negative 10. So I could write it like this, or I could just multiply my 9 and my 1, and the best way to write it would be 9 over x to the 10th. Again, both valid ways of doing it. Okay, last one is probably the trickiest. I will write this in, I'll write this in red. I don't know. I'm going to write this in black first because I think I can do it without fractions first. We'll see what I end up with. So first thing you need to do is distribute that negative 2 exponent. So I get x to the negative 6 because I'm multiplying my exponents over y to the negative 2. Okay, now I have a couple options. I could basically flip that second fraction around and then deal with it, or I could just multiply straight across. X to the 7th times x to the negative 6th, add the exponents, that's x to the 1st, y to the 5 times y to the negative 2 is y to the third. Oh, I should have written that in red because I got the other way first. So I got x over y to the third. So if I wanted to write it with just positive exponents, that would be how I'd write it. So this time I need to go the other way. Let's say I didn't want a fraction as part of my answer. I could leave that as an x, and if I moved this to the top, I would not be able to leave it as y to the third. I'd have to write it as y to the negative 3. Okay, so, and again, that one should have been in black, my bad. Because that's how I'd write it without a denominator. Okay, so there's always two ways to write the answer, but those are your two standard ways. You would never, the biggest thing I think you can pay attention to in your answer is you never want to have a negative exponent as part of a fraction. Okay, at that point, it's kind of like, it's really redundant. Why would you want a negative exponent in your denominator when you could just have a positive one in your numerator? So if you have fractions, use only positive exponents. If you use negative exponents, just make sure you don't have any fractions, okay? That's it for this one.